Now that we know how to use Ohm's law with a series combination of resistors, we're in a position to fully analyze a series circuit. Okay, so for example, we have this circuit diagram here. We have two resistors hooked in series, R1 and R2, and they have values 6K and 3K respectively. And then we have a voltage source E, which is 12 volts. And we would like to find the current in the circuit and the voltage across each resistor. Okay, so solution here is given in the notes, so I'll just go through it. First thing we're going to do is find the equivalent resistance for that pair of resistors hooked in series. Because they're hooked in series, all we need to do is add the resistance values. We get 9 kiloohms. Next, we apply Ohm's law. We know I is equal to E over R. We put in the equivalent resistance that we just found, total resistance, we get 1.33 milliamps. Now we know the current in the circuit. Of course, in any series circuit, the current is the same everywhere in the circuit. And so that means this 1.33 milliamps is passing through R1, and it's also passing through R2. Well, if we know the current through a resistor, we can use Ohm's law to find the voltage across that resistor. Just multiply the current by the resistance, right? So that means that if we let V1 and V2 be the voltages across R1 and R2, then V1 is I times R1, 8 volts, and V2 is I times R2, or 4 volts. And now let's just see a little check here at the end. We know from Kirchhoff's law that the rise in the circuit is given by our source, 12 volts, must equal the sum of the voltage drops across the resistors. And it does, right? 8 plus 4 is 12 volts.